All right, we'll go ahead and get started. We have a fairly small group. If you have questions, if you wouldn't care to put them in the chat box, then I'll try to keep a check on that as we go. This presentation is focused on soils mainly in the landscape. I'm not going to talk much about soilless media, but more just actual soils out in like a home garden. My name is Amy Byington. I'm the County Ag Extension Agent in Lee County, and at one period of time, I studied soil science at Virginia Tech and was on their soil judging team. So soils has been one of my favorite things for a very, very long time. So we'll go ahead and get started. So what is soil? And I just kind of grabbed this from the NRCS website as a basic definition of unconsolidated mineral and organic material on the surface of the earth that serves as a natural media for growth of land and plants. But the main thing about soils is that it's pretty much a living and breathing thing. So it has air, it has water, it has organisms, roots. It has the mineral particles, and we'll spend a lot of time on the mineral particles. But soils is a living and breathing thing that a lot of times people don't think about and underappreciate. Soil has many different attributes. It has physical attributes, and a lot of that has to do with how it reacts to water. And then we also have chemical attributes that we normally think of as fertility. And then there's also biological attributes. And so that goes into our microorganisms and those sort of things. So as we look at these, physical attributes are really important in soils. And a lot of times people think about these and they'll call them like soil types. But we have three soil particles. We have sand, silt, and clay. Sand is our largest particle size. If you go to the beach and you feel that sand, it's very, very coarse. Sand doesn't hold water very well and doesn't hold nutrients very well. The other one that people are used to is clay. Clay is our tiniest particle size. It is super, super, super tiny. They fit well together. If you think about clay pots, the reason why that works is because it's small particles fitting together and it's able to hold water. I always refer to this as like the story of the three little bears. You have one too big, one too small, and one just right. And silt is kind of considered, your more fertile soil. It's just nice and fluffy. The nutrients work well with it. Water moves through it well. So it's kind of considered the really nice particle size. But now we can have a combination of all of these, a little bit of sand, a little bit of silt, and a little bit of clay in our soils. Some of them are more dominated by another. So we have what's called soil texture. And this is actually a chart of soil texture classes. And we actually break down these types of soils based on how they react to water, how they react to nutrients, things of those natures. And they've been grouped together into 12 soil texture classes. And they're based on what percent clay is in them, what percent silt, what percent sand. And that just gives us the ability for somebody to say, oh, I've got sandy loam, for me to know how that's going to react to different things. So if we look here, one of the reasons why it's so important is this chart here. And so in this chart, we have a line that says wilting point, and then we have a line that says fill capacity. Okay. Anything below that wilting point is unavailable water to the plant. It cannot pull it up out of the ground. Anything above fill capacity is too much water. Well, down on the axis, you can see you have these different soil texture classes: sand, sandy loam, loam, silty loam, clay loam, silt, clay, and clay. And they show you how much water on the left it takes for them to reach those points. And so if you look at that, you can see it doesn't take a whole lot of water for sand to reach wilting point or fill capacity. Versus clay, it takes a lot more water, and you still have a fairly narrow band there that the water is actually available. So that's actually looking at what those different types of soils could do and how much water is actually available to the plants. So loam, quite often you'll hear people talk about loam, and loam is a pretty good mixture of all three texture classes mostly, and you can see how it's kind of a nice point there that has a pretty wide band where water is available to plants. So soil structure is another thing. Soil will actually congregate into an aggregate, and we would call that soil structure. And on the right, I have a little diagram of some of these different soil structures. The problem one is platy, which is on the far right. If we have lots of compaction, that soil will get compacted and it will form these little layers. And water has a hard time getting through it, and so does roots. We actually want to see like that middle one, which is blocky, where roots and water have places to go. If we have a soil that's been disturbed, we'd call it massive. And it's in the bottom right of this slide. And the water and the roots don't have anywhere to go because it's not aggregated together to form something. Bulk density is another thing that we look at, which is just the amount of soil given in a volume. So those things all go together, mainly focused on compaction and making sure that roots and water have places to go. Soil biological characteristics, this is organic matter. A lot of times we'll see and can tell from looking at it, but we'll also do tests on what kind of organic matter we have. And of course, whenever you dig down into soil and you have earthworms and those types of things, we know that our soil is healthy whenever we can see those kind of things. But today we're going to focus quite a bit on fertility. And soil fertility is chemistry. So you have all this going on in soils, and people a lot of times don't even realize it. But around soil particles, you'll have water and water solution, and you will have all this chemistry going on. We'll have anions and cations, plus and minuses, and different nutrients will be attracted to other sets of nutrients and things like that. And we can actually have nutrients bound up by other sets of nutrients. So there's a lot of things that go into soil chemistry. We're going to break it down as simple as I could think to do it. To start with, we're going to look at our main nutrients. And so this is a barrel. It's kind of the pretty common law of the minimum. So whichever nutrient is at its lowest point is actually how much yield we're going to have. And so when you go buy fertilizer, you will go buy NPK, which is nitrogen, phosphorus, potassium, most likely. Those are our three common limiting nutrients. When you go buy 10-10-10, you're actually buying 10% nitrogen, 10% phosphorus, and 10% potassium. And the reason why those are our three is because they're the most limited. They're the ones that we need the most quantity of. And that's why normally when you go buy fertilizer, that's what you get. Now, as we look next, our next limiting one is sulfur. In the past, we've not had to worry about sulfur. We had acid rain, and it came in the form of acid rain, but we've done a lot of work on cleaning up our power plants and cleaning up acid rain. So we're actually starting to see some deficiencies in sulfur. I haven't seen them in home gardens, but I have seen them in crop fields. Our next two are calcium and magnesium, and we'll talk more about them later. They're tied to liming, but they are needing a good amount in our soil, and people are kind of surprised to know that they're that important. And then we have what we call the micronutrients, and so this is your magnesium, not your magnesium, your boron, your manganese, your zinc, copper, iron, and these are considered your micronutrients usually. And we can get these added to our fertilizer, or sometimes you can get specific things for each one of these. And sometimes they make fertilizers that are specific to one crop that might have a need specifically for one of these more than others. They're all very important and needed. It's just that we don't need them in as high of a quantity. So here's just an overview of nitrogen, phosphorus, and potassium. The main thing about nitrogen is that it likes to leave us. As soon as we spread nitrogen, it likes to find a way to go somewhere else. Phosphorus isn't as bad. It has become an issue as a pollutant in the streams, but it's mainly due to erosion. And it can be very unavailable due to iron and aluminum in our soil having a low pH. On the other, then if we have a high pH, it can be tied up by calcium. So it can be elusive because of that. And then potassium's not readily lost from our soils. Most of it comes from parent material, but it's in the parent material form, it's immobile in the soil. So we actually have to break it down and have it available, and that's its issue. So we can see this a little bit better in on this slide. So the red is all the lost pathways for nitrogen. So nitrogen, literally, it likes to either evaporate, it will erode off, it will leach, or it can do what's called denitrification, where we have too much water and it will actually transpose into an unusable form. So nitrogen can be pretty elusive in the environment. We have different ways that we can bring nitrogen into the environment, including legume plants, which are very, very handy to have. And even snow can bring in nitrogen. But nitrogen can definitely be hard to deal with. Phosphorus isn't as bad. As you can see, the lost pathways, they have erosion and runoff and leaching, which is usually pretty minor. We do have several ways that we can get it, but for the most part, fertilizers and animal manures are our main things to get phosphorus. Potassium, also again, can have runoff, can have some leaching. The main issue is there's not a lot of ways to get nitrogen in the system other than fertilizer, having some already in the soil, and then manure. So micronutrients, again, just as important, just needed in lower amounts. Quite often when we have a micronutrient deficiency, people will perceive it as a disease. And it's actually a deficiency. One of the common things I find home gardeners do is they'll use Epsom salts around their tomatoes, and I'll ask them why, and they say they grow better tomatoes, but actually what they're trying to do, whether they realize it or not, is increase magnesium to prevent deficiencies in tomatoes. So pH is very, very important in soil chemistry and fertility. If you don't know what pH is, I've got just a simple, well, actually it's not simple, fairly long explanation of what pH is, but I'm going to explain pH as simply as it's on a scale from 0 to 14, with 7 being neutral, usually referred to as your general water. And on that scale, as you move one way or the other, it becomes more acidic or more basic. And so as we go up and down that scale, different things happen chemically. And so we can look at this differently for different plants. But pH determines what nutrients are actually available, and you can actually use lime or even sulfur to alter this one way or one direction or another. And some crops have different pHs they want to live in. So blueberries, pretty commonly people want to plant blueberries and they'll plant them in their home garden and they won't do well. And usually the reason is because the pH is too high. And blueberries like a very low pH of 4 or 5. And if it gets too high, they'll actually have iron deficiency. First is corn, which likes to have a nice pH somewhere around 6. And we can see that here. This is a really nice diagram that I like. You have your pHs on the bottom, and then each band is a different nutrient, and how wide that band is how available it is. So if it's a narrow band, it's not really available. If it's a wide band and in the green, it's very available. So if you look at that, between 6.5 and 7, most things are very, very available. So if we look at this, the question then becomes, well, why would blueberries want to be all the way down in 4 or 5? Well, blueberries are traditionally in the mountains. They're in poorer soils, and they like a lot of iron. And you can see how that iron changes as the pH increases. So they like iron, and they can tolerate not having all these other nutrients in larger quantities. Each plant is different. And actually here we have a chart of the preferred pH of different plants. If you can see, beets on here is actually likes what you call a sweeter soil. So they like a soil that's more basic. So 6.5 to 8 is actually what it prefers. Then you have potatoes, who are a little bit more forgiving, and they can have a acidity down to 4.8 to 6.5. So pH depends on what kind of crop you're dealing with, and sometimes we need to look at this if we're having issues. Lime. I always say lime is our cheapest fertilizer. You can get it from any garden store. If you get what's called dolomitic lime, it will also supplement your magnesium, and it always supplements your calcium. A lot of times people do not understand that lime is not just calcium, it's calcium carbonate normally. And we're actually after the carbonate to neutralize the acid. And so I actually have the equation here at the bottom. And it has the hydrogen particle onto the soil particle, and then we have the calcium carbonate. Once rain happens, those bonds can release, and that calcium will attach onto that clay particle, meaning that we'll have that calcium will be available for our plants. And then the carbonate attaches onto the hydrogen, and it becomes carbonic acid. And that neutralizes our acid problem. And that carbonic acid is not very stable in the soil. And so what it does is it eventually, on its own, breaks down into water and carbon dioxide. And that's how lime actually works. So when you're buying lime, you're not wanting just a product that's just got calcium in it. That calcium's not actually neutralizing acid. That calcium is actually a nutrient that you need. And you're looking for that carbonate to take care of your acidity issue. So this is actually a pretty nice table from the University of Kentucky. They have a wonderful home gardening, pretty thick guide. It has lots of things in it. I've got it referenced at the bottom, but I also have it at the end of the presentation. And this is their chart for like a home garden if you wanted to raise your pH or lower your pH. And they've got it in 1,000 square feet. If you do a soil test, which we'll talk about here in a minute, we'll also tell you how much to do. But if you were wanting to do maybe something different, you could actually go on here and change it if you had a soil test. It does require getting a buffer pH, which we'd have to have from a soil test. But it's a pretty nice table, at least even for the sulfur. So if you were wanting to plant blueberries and say you found that your pH was 7, it does have on here how much you need to do of elemental sulfur to get that down. So another attribute that we like to look at for soil chemistry is cation exchange capacity. Most nutrients, not all, most nutrients are cations, so they've got a little plus. And the more of those you have in our soil, the more that we probably are more fertile it is, okay? And this little diagram on the far right, it says 0 CC, sand. And that's because sand just does not hold nutrients. It doesn't have any receptor sites. And on the left, you see 50 CC. Well, that's heavy clay, and that's because clay has all kinds of sites to actually have fertility. But clay also usually comes with aluminum and iron, which can kind of tie up some of our nutrients. But the higher that CEC is, the more cations you have and more nutrients you have in your soil. And that's just something that we kind of look at, especially on soil tests. So how do I know what my soil condition is in? Well, we soil test. You can get your soil tested done at Virginia Tech. It just costs $10 for a sample. And that gives you the whole gamut of everything going on. You can do just a home garden sample. You can do a lawn sample. If you're growing to sell, you can actually send off specific crops, and we'll give you specific recommendations for that. Sometimes I have people ask me, I bought an at-home test kit. Isn't that just as good? Some of the question I would have is like the accuracy of that test. And the other thing is the pH. And so with the pH, I want to have that buffer pH because it refers to what we call reserve acidity. And so when we break up bonds of nutrients with lime, we might have more acidity that comes out, and what's called reserve acidity. So I won't know that with a home test kit. Now, the home test kit might tell me, I should get a soil test because I'm at pH of 5, and I should probably need a lime. But to have a real good idea of how much lime to use, I really need to have a lab test done. Now, you have other labs that can do this, but Virginia Tech can do it in our state. Another thing you can do to look more up about your soils is that there's Web Soil Survey. You can get on there, you can type in your address, and it'll tell you what kind of soil you have. A lot of times we use this more for bigger fields, but you can look at your yard and that sort of thing. And see what kind of soil you have, what kind of limitations it has. It can get in pretty detail. I actually pulled up my farm there and pulled up like the rankings for growing, I think, trees. Yeah, the tree site index for northern red oak is what I pulled up from my farm. All right. So you would get your soil test stuff from your local extension office. This is the form you would get. It's a pretty simple form, mainly your contact information, your sample identification. They give you a box, and the box has a place for you to put your sample identification. And you can put whatever you want, whatever you will remember. 1, 2, 3. You could, whatever you would like that you would remember. Your plants to be grown would come from the right. You have little codes over there that you could put in, and then they ask you when the last time it was that you limed. And then you would just click routine test, and you would send that off to Virginia Tech. So how do we soil sample? We try to sample in the general area. If you have specific areas that are trouble, we try to avoid them. This is more of an issue if we're doing big fields versus doing a home garden. So for this, not necessarily as applicable for what we're talking about, but good to keep in mind that if there's something kind of weird sticking out, we may not want to sample there or sample separately. You can use all kinds of different tools. You can use a hand trowel, you can use a shovel, you can use an actual soil tester. When you take these samples, though, you want to actually take all the way down a cross section so that shovel down there in the bottom, you see that you actually have like that cross section going down. That's what you're wanting to collect. You don't want to just take straight from the top. You want to take as you go down. When you take these soil samples, you need to use either a clean bucket, or a lot of times I will use a shopping bag. I will just get like a Walmart bag, and I will use it because I know it hasn't had fertilizer in it, and then I can crumble it up, mix the soil up without having to get my hands super dirty. When we take these soil samples, we want to take subsamples. So for home garden, we want at least 5 subsamples. So you need to go zigzag through your garden about 5 times at least to grab that sample and mix it up. When you're talking about doing a garden, you need to go down 6 or 8 inches wherever that tilled area is of the garden. And that's what you're trying to get. And you're trying to get that subsection and get those subsamples and mix them together and put it in the box. Okay? Let's see here. You fill out the paperwork and you mail it to Virginia Tech, and they will send you back soil test results. And so your soil test results would look like this for a home garden. So this one person sent off for a vegetable garden. And we're going to look at a couple things on here. So the first couple things we're going to look at are our fertilizer recommendations. So the fertilizer recommendations for this, I have highlighted the P and K. There's a rating there at the bottom, and it says VH. That stands for very high. And so the phosphorus and potassium in this was very high. One thing you notice that there's nowhere on here that says nitrogen. And the reason why is that these lost pathways are so much. Like we can lose nitrogen in so many different ways. We kind of just assume we don't have any, that you're going to have to supplement one way or the other unless you're doing a legume, like a legume cover crop or something. So nitrogen's not on here because we could test for it today and it would be different than by the time you got the sample. So we don't usually test for it. So if we look down at the recommendations, it actually gives you the recommendations, what fertilizer to buy. And if you can't buy those, it even goes down and says, well, use 10-10-10, and you need 4 cups of 10-10-10 per 100 square feet. So that's pretty simple for home gardeners to do, and gives you roughly what you need to do. If we look now, let's see here. If we look at the micronutrients, the lower level, the ratings, you can see zinc, manganese, copper, iron, and boron, and they say SUFF, that stands for sufficient. If there was an issue, they would send you specific directions on how to handle that issue. A common one's like boron, and they would send you specific directions on buying like borax and using it, or a different type of product. So all those were sufficient, so we were good. So we don't have any specific recommendations for it. And then we can look at our pH and our lime. So you see soil pH was 6.8. That's really good for a vegetable garden. And beside of it, we have buffer index. That's what I was talking about before with like the reserve acidity. That's not something you can test usually in a home kit. And so that's why I kind of recommend you mail off and do a soil sample. And then we have the CEC, and it's actually pretty high, pretty good looking at it. And then I've also highlighted the calcium and the magnesium. And the reason why is, again, when we use lime, we get calcium and sometimes we get magnesium depending on the product. So if we've been liming properly, then guess what? Our pH is good and so is our lime and magnesium. Sometimes you'll have lime as a filler in some of your fertilizer products, so you may not realize, like, why is my pH that high? Well, it's because some of the fertilizer products you've bought, they've put in some lime as a filler. So deficiencies. This is actually a long list of what different deficiencies look like, but I've got some pictures. And at the end, if you want my PowerPoint, I have my email address, and I don't care to send it to you. So you have all these. And this is just a little diagram that tries to put all of them on there. And when you look at this, nitrogen, a lot of times it's the upper leaves, and they'll look lighter, like a light green, and then your lower leaves will like become really yellow, and your bottom leaves, they'll get like shriveled up. Phosphorus, we get kind of a purple color. We lose leaves. I think it'd be better if I show you the specific picture. So here's nitrogen and corn. And so you can kind of look and see how the yellowing at the bottom of those leaves are versus the light greens above. Here's phosphorus, is the purple I was talking about that you can see. Here's potassium. We call it burning around the edges. And so around the edges, it will kind of look like it's dying. Calcium, we actually have a disease that we call blossom end rot, and that's actually a calcium deficiency. A lot of times people have a hard time with this because they'll be like, but I had calcium in my soil. But different parts and times of the summer, we may not be getting enough rain for that to actually pull it up out of the ground in a usable form. So we may still have this issue. And usually to fix it, you're actually spraying a calcium product on the plant. Sulfur kind of just turns a light yellow, looks very weak. Here's iron. You see how those mid ribs is actually dark green, but the rest is yellow. Here's boron. Now this one I see quite often in home gardens. Somebody will grow some type of cold crop, so they'll grow like broccoli or cauliflower or cabbage, and the center part will be holed out, like an insect's been in it, and it's actually a boron deficiency. That's usually where I see that at, and you can actually get borax laundry detergent, and we can actually use that as a fertilizer for that. Magnesium, this is on a tomato. I actually grow pumpkins, and I'll actually even use Epsom salts on my pumpkins. But a lot of times using Epsom salts, if we had something like this, we would use Epsom salts and we'd be spraying the plant with a mixture with that. But it almost looks like a disease, but it's truly a nutrient deficiency. And here's manganese. Not very common for me to see this, but sometimes in the greenhouse sort of stuff, you might see this more so in manganese, and very similar kind of to like the iron look. And what are these nutrients used for? Lots of different things. All of them are very important. I just found this very interesting, and I kind of left it in here. And we won't talk too much about it just due to time. But soulless media, just a few comments on that. Your soulless media, we're trying to replicate what the soil already does naturally. Usually your major components are peat moss, perlite, and vermiculite. And so the peat moss a lot of times has a lower pH, so sometimes we have to deal with that, and we need to watch. Perlite is there really to kind of help with that porosity, trying to help have a passageway for the roots. It's bigger, so there's ways for roots to go around and water to go around. And vermiculite is actually can develop into clay, and it can have some nutrient capabilities, hold things together. Sometimes some other things you'll see in soilless media are sand or bark or lime. You may get wetting agents, fertilizer, but there's a whole lot going into soilless media because you're trying to replicate what soil already does. Soil tests for this is completely different, and there's so many different options out there. But some resources that I really like, I've highlighted here, that are really good to access. And here's the University of Kentucky home vegetable gardening one I really like for home gardeners. But if anybody has any questions, you can either unmute yourself and ask or type them into the chat. And here's my contact information. If you have any specific questions or if you want this PowerPoint, feel free to contact me and we can take care of it.